Hey students, we are going to learn synchronous counter. Before starting synchronous counter, we are going to revise a little bit what is counter. Um, the digital circuit used for counting pulses is known as a counter. It is a sequential circuit. Counters is the widest application of flip-flop. It is a group of flip-flop with a clock signal applied. Counters count the number of clock pulses. Hence, some modifications it can be used for measuring frequency of time period. There are mainly two types of counter, asynchronous and synchronous counter. On previous video we have learned asynchronous ripple counter. Now we are going to start synchronous counter. In synchronous counters, all the flip-flop receive the external clock pulse simultaneously. Like ring counter and Johnson counter are the example of synchronous counter. Asynchronous counter are easy to understand, but avoid their uses. Slow, limited by propagate delay. It is error prone. In synchronous counter, we are not going to generate sequences. Characteristics of synchronous counter: use common clock pulses to trigger all the flip-flops. A single common clock pulse is applied over all the flip-flops. Have a higher clock speed. Hardware is more complex but more reliable. These are the advantage or characteristics of synchronous counter. A 4-bit counter, synchronous counter, which we can say serial enable logics. Here we can take single clock that is applied to all our flip-flops. The enable input, first one that is called LSP and this one is called MSP. Output of Q0 that is input of AND gate and CN10 input. Same way output of this that is giving input of next and Q1 that is giving as the input of next gate for ANDing operation. It is simple block diagram. It is called serial enable logic. Now parallel enable logic, in which CN10 input that is parallel input to each and every gates and output of Q0 that is giving as input of next gate for each and every for generate counters. Here that is LSP and here next one that is MSP. This 0, 1, 2 and 3. MSI counter. Counter can be built from individual SSI flip-flops, example 7470, 7474, 7479 and many more. These all are remaining. We are going to learn 74 cross 163. Next, MSI counter, 4-bit synchronous counter, age trigger, synchronously presentable, cascadable, typical count rate of 35 MHz, 160 and 162 mode 10, 161, 163 mode 16. Here we can see the diagram in which logic symbol is there, pin diagram is there, 4-bit counter is there, pin diagram for this counter. MSI counter 74LS 164-bit synchronous counter, in which we can say it is called pin number 1 from round cut, right side 1, 2, 3, 4, etc. PE that is parallel enable active low input, that is PE bar, pin number 9, P0 to P3 parallel inputs, P0 to P3, P0, P1, P2, P3 are parallel inputs. CEP that is count enable parallel output input, CEP. that is count enable parallel input, count enable trickle input, that is called CET, CP, active high going edge clock input, that is CP, pin number 2, MR bar master reset active low input, that is MR bar, SR bar, that is called synchronous reset active low input, Q0 to Q3, that is for parallel output, Q0 to Q3, that is for parallel output, and TC, that is called terminal count output. Terminal count output. It is over here. It is node A, node B. You can say node A, node B. It is simple pin diagram of MSI counter 74LS163 4-bit synchronous counter. It is edge trigger, synchronous, presentable, cascading, and count modulo 16 binary. Synchronous reset clear input that overrides all the control inputs. It is pin diagram in which we have already discussed all the pin. Parallel input, parallel output, CPT, CEP, CP, that is clock pulse. It is block diagram of pin. 74LS160 logic symbol. Dataset is also available. Here we can say input active low 1 and 7, 1 and 9, that is active low, 3, 4, 5, 6, ABCD, QA, QB, QC, QD, output lines, CEP, that is counter enable parallel input, CET, that is counter enable trickle input, that is CET, terminal, that is TC. This all are already we have discussed. 74LS state diagram and logic equations. It is state total 0, 1, 2, 3, 4 up to 15. It is 16 bit. That is reset, that is P bar dot CP plus rising clock edge. Reset, that is SR bar dot CP plus rising clock edge. It is transit 0 starting from 1, 1 to 2, 2 to 3, 3 to 4 up to it become now on 0. MSI counter, all signals must be high. It is H to enable the counter sequence to be. Signals are SR, PE, CET, CP, L, reset the clear, reset or clear, H, L don't care, load, PN to QN, all H, count increment. HHHL don't care, no change, it is whole. Next one, that is also whole. MSI counter, that is 74 cross 163 synchronous counter. Here we can see diagram of input state, current state and next state for 16 bit. It is for current state and next state. It is also block diagram. The control inputs. Here we are following effects, mainly where 0 and don't care, 1 0, 1 1, 1 1. At that time, it is going to select D, QD, QD, QC, QC, QB, QB and QA, QA. And remaining all time, whenever it is clear, all the values are 0. Load, CLR1 load, DCBAR load, hold, QD, QC, QB, QL hold, and whenever once again hold, that is QD, QB, QA. It is internal logic diagram. board IC in which number of inputs are there, flip-flops are there, input that is ABCD and output QA, QB, QC and QD. Thank you.